Okay, welcome to Besti by Weird Dudes.
Yes, we know how much Besti we're talking about today, so
uh, so yeah, Besti scene because I haven't like AS paper मुझे कुछ याद नहीं है. Although I should remember वैसे. So let's see how this goes. But we have Hamza to catch me on the
definitely.
call. So chilling it. The table shows in the information about some of the elements in the third period. Complete the table to show the maximum oxidation number of each element. तो यार with metals तो chilling है. Metals की तो क्योंकि बेचारों की these are not your transition metals, but period 3 में तो इनकी बस एक ही oxidation state होती है. If you remember, so non-metals they used to they can undergo octet expansion because they have a vacant d orbital, and इनकी like दी हुई है very nicely chlorine की +7 तो सबकी एक कम होती है. Um, Obviously if you remember the concept you can figure out why. If you don't remember the concept, just remember some popular compounds, right? So for P it would used to make PCl3, and more importantly PCl5 the इसके +5 है. S can make SO2, but more importantly can make SO3. तो obviously oxygen -2 होता है, इधर -6 हो जाएगा, इधर +6 आ जाएगा. So like just use a little knowledge to get the answer as well. Okay,
Otherwise, if all else fails, you can just drop the orbitals and see how many electrons you can promote to the d orbital, and then make
Yeah.
compounds out of it.
Yeah. Should we do that? Yeah. Do you think इतना लोगों को आता होगा?
I think no, I don't think we need to do it. And secondly, it's just for 1 mark. So if you have time at the end of the paper, sure, do it. But otherwise, it isn't worth it.
सही है. एक मार्क तुम लोग छोड़ देना, टेंशन नहीं. Explain why the atomic radius of elements in the third period decreases from Na to Cl. इसमें जरा wording का जरा ख्याल रखना पड़ता है given the marks. So 3 marks, so you need 3 proper points, right? So here was nuclear charge increases. What I mean by nuclear charge, I mean the charge of the nucleus. As simple as that. Atomic number increases, right? So protons are being added to the nucleus. So nucleus में charge ज़्यादा है. However, something you need to clarify and you need to emphasize here that electrons are filled in same shell. इसकी significance ये है, you can either write that whatever. By saying same shell, it means the shielding effect is unchanged. So जब shells different होते हैं तो फिर shielding effect आता है. So charge बढ़ रहा है, nuclear charge बढ़ रहा है, electrons are filled in the same shell. So your nuclear force of attraction, the force of attraction between the nucleus and the electrons, that increases. Because of that, your radius decreases. The radius of the most common ion of Mg is much smaller than the radius of the most common ion of S. Okay. So yeah, identify both ions and explain the difference in their radii. यार magnesium का बेचारा most common ion, magnesium का तो एक ही ion है. सही है. Sulfur can have a lot, but the most common ion normally is the electron arrangement. Just say it will behave like a noble gas. So वैसे sulfur किस कौन से group में होता है? It's like what, group 6? Right.
Yeah, it's below.
Yeah, so sulfur is here, so it needs to gain 2 electrons to become like a noble gas, and that's going to be its most common ion, right? So sorry, मैं क्या लिख रहा हूँ? 2 power 2 minus sulfur 2 power 2 sulfur 2 minus, right? Explain the difference in radii. Yeah, if you look here, magnesium ये था, magnesium lost 2 electrons to go here, so it has an electron configuration similar to neon. Sulfur has a configuration similar to argon. Either 2 mark है तो probably 1 mark for identifying the ion. The second mark you just simply write कि इसका obviously radius ज़्यादा होएगा. इसका radius is more than magnesium. Why? Because as we saw, it's इसकी electronic configuration argon से similar है rather than neon. So it has 1 extra shell when you compare to Mg2 positive. If they wanted another point, I don't think they do here, but if you wanted to know, then another way to look at this is that magnesium 2 positive may, because it's lost 2 electrons, but the protons are obviously still the same. So there are now more protons than electrons. So the nuclear force of attraction then further dominates because it's more. I mean, instead of 10 protons attracting 10 electrons, it's now whatever how many protons are attracting 2 less electrons. So it's easier. और भी ज़्यादा खींच लेंगे, और भी radius छोटा आता है. In the case of where you're gaining electrons, in the case of sulfur, for example, then you have stuff like electron repulsion and all of that type of stuff. So that just further even I don't know, expands increases the radius a bit. Yeah, फूल जाते हैं. I don't know how else to put it. So yeah,
that's a much better word.
Phosphorus is a non-metal in the third period. Chalo, thank you. पता नहीं था. It reacts vigorously in excess oxygen, but slowly with chlorine. Some reactions of phosphorus are shown to represent the formation of compound A. So yeah, again, the idea here is, वैसे तो phosphorus, if you remember, it can form PCl3, it can form PCl5. So it does exist in 3 positive oxidation state. The more stable state would be 5 positive. And here देखो excess O2 है, so like further oxidation का chances बहुत ज़्यादा है, right? It's very unlikely कि आप 3 positive के state में रुक जाए. Excess O2 है, it would react till its maximum oxidation state because oxidation ही हो रही है ना, in a way, if you can think of it like that. So you want to form something that has an oxide of phosphorus that has 5 positive. So अगर 5 positive करना है, I would say oxygen -2 होता है, oxygen को -10 अगर आपने करना चाहो, इससे 5 कर लो, इससे into 2 कर लो. This could be your oxide. हमजा वैसे phosphorus की oxide को याद है कोई से?
यही दो ही हैं because it repeats very frequently ना. ये question आते हैं. The most common kind of question about this is name 2 oxides, name 2 elements which have the same kind of which have 2 oxides or more. So उसमें whenever the marking scheme suggests such an answer, it always says either P4O10 or P2O3. So it gives one of each oxidation number.
So yeah, so +5 के लिए I have to get 2.5 5/2 O2, or you could just multiply the entire.
Yeah, you should use P4O10 though. Whenever it uses P2, it usually uses P2O3. Yeah. Whenever it says P4, it uses P4O10. So.
I'm sorry?
I'm just saying whenever it mentions P2, it uses P2O3. The marking scheme usually suggests that. And whenever it uses a configuration of P4, it usually uses P4O10. So try to keep it between those two things. That's generally what the marking scheme suggests. Okay, sir.
There again, diya by P2O5. Yeah, but I mean, because the idea here is, I gave the reasoning why you want +5 key oxidation state instead of +3 on phosphorus. So you just balance it in such a way. It's अच्छा है multiply by 2 पूरी चीज को कर लो ताकि you don't have the 5/2 awkward balancing with oxygen. मतलब ये just to get rid of this, so आप वो भी कर लो and whatever, like it works, they accept it. काम चलता है तो काम सही है. That's okay. So give 2 observations you could make in reaction 2. Reaction 2 is you have chlorine gas reacting with phosphorus to form PCl5 solid. ये white solid होता है ना?
ये white solid होता है.
So what observations is what you can see. So white solid, chlorine का वो कोई गंदा कलर होता था, वो yellow green
कहते हैं उसे.
Yeah, yellowish.
The easiest way to remember.
Yellowish कोई नहीं बोलता हमसा. It's yellow green.
Yellowish. अच्छा मुझे तो it sounds more like continuity रहती है word. Yellowish green.
तुम वो ऐसे बच्चे हो जो O levels में वो जो होता है ना कि कौन सी बुक थी उसमें dirty green precipitate वो रट्टा मार के आगे वो भी dirty green नहीं होता, वो green होता है. क्या है वो?
अच्छा ऐसे that's actually the first time I'm hearing it वैसे, but चलो तुमने अगर पढ़ा है तो I'll take your word for it.
What's a dirty color यार? मतलब
हाँ नहीं, I think it's that dark murky सा color ना जो usually when you think about it आपके ज़हन में swamp जैसी चीजें आती हैं. So
I don't know. I just used to read dirty green. I'm like, they didn't have a better word for this. But khair, back to the paper. So yellow green gas. Well, you can't. Well, basically, the idea is it yeah to decolorizes. You see the color disappear, decolor. मैंने क्या लिखा है? Okay. Yellow green. Sorry, let's keep it easy English. Color disappear. Easy for me to spell. This is
The
an
spelling of disappear is wrong, Essen.
yeah. अबे तो
You only have one S.
अबे chilling. I don't know on
Achha,
purpose.
chalo.
I'm seeing how alert our viewers are. So yeah. So
About chemistry, not English.
name compound B. So compound B is हमने PCl5 को डाल दिया पानी में. So yeah. So again, if you remember small, Sarojana इसी तरीके से पढ़ा था. So small size, greater charge वाला idea. Basically, the idea is as you move left to right in period 3, the chlorides become more acidic, right? So we're going to be looking here to form some sort of क्या कहते हैं acidic तो खैर HCl हो रहा है HCl निकल रहा है so PCl5 पानी में डालो
Essen, the smaller size greater charge ion concept applies to group 2 elements mostly. Not across the period, it's down the group.
Yeah, across the period भी आप कर सकते हो. I mean, I don't know, Sarojana ने ये तो पढ़ाया था, that's for sure. Because like left to right भी, you know, charge.
Radius कम होता है.
Yeah, that wise. But obviously, it's more potent down the group because left to right radius इतना कम होता है. Yeah, उधर तो like Shelly बदल गया ना, तो उधर तो like crazy scene हो गया. सही है. Sorry, ये मुझे क्यों नहीं याद आ रहा? Compound B हमने PCl5 डाला. सही है. हमने पानी डाला इसमें. You got HCl. And हमें क्या बनाना है? Oxide बना लें?
नहीं, हमें acid बनाना है because you're adding a P compound ना, तो for example, बस to remember this, it's easier to think of SO3 को पानी में डालते हो, so you know it's acidic, it forms sulfuric acid. So इसी तरह whenever you add this, you're going to form phosphoric acid. That's a nice analogy to remember.
So phosphoric acid H3 इसका plus 5 है. So H3 PO4. And if you're like me who never remembers कि you know 4 आता है 3 आता है, just remember इधर +5 था, इधर ये +3 हो गया. This is -8, so it has to be +5. So you know you've written what जो भी लिखा है आपने सही से लिखा है. That's the thing. सही है. तो if we balance सही है, इधर 4 आपके इधर आ गए नहीं तो 5. Oh, so you would take 5 of this, right? Which
Essen, it isn't asking the equation. It's just asking you to name compound B.
So excellent, very high level tip number 1. Read the question. So name compound. Compound B. Phosphoric
acid.
Selenium.
Although you might want to enter the oxidation, Essen, you need to enter the oxidation number as well when you're writing it in English. No? You have to add phosphoric penta 5 acid basically.
Yeah, but if it's +3 here, and this is still H3 most probably, then O6 नहीं. So O3 हो जाता है ना, Hamza? If it's like अगर P की oxidation state +3 है, so this would be, I believe, phosphorus acid rather than phosphoric acid. But like let's just check the marking. Phosphoric 5 acid. चलो तो good है, good habit. Phosphoric 5 acid, no harm done. हाँ लेकिन like I mean if they use
it's
sorry?
It's better to remember this trend. I was just saying that whenever they use things like disproportionation, yeah, they ask you to mention the name of a compound or ion, and you're naming it in English, the marking scheme always mentions its oxidation number in terms of, you know, Roman numerals, because usually when it's talking about not alkyl halides, or any of these elements with variable oxidation numbers, the idea is it can form multiple compounds. So you have to specify which one you're talking about.
Okay, I will specify from now on. I'm sorry.
Thank you, sir.
Selenium is a lanthanoid metal. Okay, God knows what that is.
Those at the bottom of the periodic table, na?
It's a cool metal that shows similar chemical reactions to some elements in the third period. Most of cerium's compounds contain and like देखो, so they do this a lot. They like एक metal देंगे that you're like ये bro ये क्या चीज है, and then they're like similar chemical reactions to some elements in the third period. So that's your cue. So they'll just be forming like some sort of link or some sort of similarity देख रहे होंगे. So it shows the same structure and bonding as a typical metal. Draw a label diagram to show the structure and bonding in cerium. सही है. So like structure उसका metallic structure में exist करेगा. Metallic lattice जो होता है उसका with Ce3 positive ions. How did you used to make this? Did you make the डब्बा square बना देते cuboid?
नहीं. You just make spheres basically, and then you make electrons to show a sea of electrons.
Delocalized सही है. Okay. I don't know because A2
You have to show their charge.
Sorry?
You have to show their charges. मैं कह रहा था, but हाँ, what were you telling about A2?
नहीं उसमें ऐसी तफरियां होती नहीं है ना, like that's the thing.
नहीं, you don't draw lines वैसे ऐसे.
ये तो negative charge है ना.
This comes off as very. हाँ, just make an electron E बना दो, हाँ.
हाँ, basically. So like yeah, a little closer. Yeah, a little closer than what I like made, but like you get the idea. Positives and negatives basically. So yeah, and that shows structure, that shows bonding as well. So because structure में ही metallic bonds उसके आ जाते हैं. These are like metallic bonds. So so ये जो इसकी 4 oxide है, so it's +4 here is a ceramic. So there's 2 physical properties of cerium 4 oxide. So there should be high physical properties, so high melting point, boiling point, right? And ceramic kind of gives you a hint. And anyways, it's ionic compound है. Hamza, ionic compound की और क्या देख सकते हैं हम? Density wise देख सकते हैं.
और one thing that pops out to me is that it has an oxidation number of 4, and period 3 में silicon has an oxidation number of 4. So I think you can pretty much match silicon's property with this selenium, whatever it is, cerium 4 oxide.
Yeah, and it's a ceramic, right? Like so.
Yeah. What is a ceramic वैसे in terms of chemical properties?
Yeah, isn't it वो वाली चीज जो ना मिट्टी के बर्तन? Let's Google to be sure. Ceramic. Yeah, ये मिट्टी के बर्तन जो होते हैं ना.
हाँ, वो तो I know, but in terms of chemistry, held in ion.
मतलब उसकी obviously high, मतलब मिट्टी के बर्तन है यार, मतलब हांडी है यार, मतलब तो उसके high melting point, high boiling point तो होगी ना.
That is a wonderful analogy.
Okay. ये तो density आप बोल दो, high density, and which can you think of anything else?
I think अगर मेरे दिमाग में तो silicon वाला चल रहा है, so it's a semiconductor. I think you could mention it.
So let's semiconductor.
Although I'm not so sure about that.
Yeah. So let's check the marking thing before we do tafriya. So high melting point, boiling point, electrical insulator. Okay, lol. Hard, rigid, remain strength. So yeah. So basically, yeah, this is ज़्यादा pink करना था from the idea is ceramic, मतलब मिट्टी का बर्तन है. So like high density.
No, but
sorry.
ऐसे मिट्टी के बर्तन are usually very soft. Now it says it's hard.
No, the मिट्टी के बर्तन are hard. They're hard AF. They're brittle, yes. टूट जाते हैं, but they're not malleable, not soft. Like,
okay, on terms में you can say that.
सही है, but like, suck on it. Okay. So we are solving on spot, so khair we to get things wrong as well. A naturally occurring sample of cerium contains only 4 isotopes. Data for 3 isotopes are shown in the data for 3 isotopes. 3 of the isotopes are shown. Is shown here? Okay, same. So the I don't know. The AR of the sample is this. Use the data to calculate the relative isotopic mass of the fourth isotope in this sample. Give your answer through 3 decimal places. Ismail, you had a nice formula. Hamza, do you remember it?
Yeah, I know. The formula can I itna basically you're just calculating the percentage of each. You know the percentage, where it's mentioned here. So you make it, the first one is 135.907 multiply by 0.185 upon 100. Multiply by 0.185. That's basically the percentage. Plus
Yeah.
the next one, plus the next one equals to the AR mentioned in the question.
So yeah, so this is 136 plus whatever आपके जो 138. मतलब basically you take this, you multiply 0.251.
No, as in you
Huh?
don't take that. You take the 137.906 and the 135.907.
Yeah, you take this. My bad. Because obviously like बना तो same आ जाएगा like. हाँ. My bad. So you take yeah I why don't we have this type of stuff in A2? Like, okay, so you take the 135.907. Oh my god, I can't write all of this. Hopefully you get how to solve it by now. If you don't, well, that is slightly sad.
There's just I think there's just one thing else in this. Sometimes it's pretty easy. Where you just have to subtract the first three from 100 to get the last
Yeah.
percentage abundance.
So for this, idea is कि you need इन सब की percentage abundance. वैसे हमजा इधर हम divide by 100 नहीं करेंगे 0.185 and all पे.
ऐसे इट सेज परसेंटेज abundance, right? तो वो परसेंट की टर्म्स में दी हुई है. या तो तुम डिवाइड बाय 100 करो, लास्ट वाले को डिवाइड बाय 100, देन यू सब्ट्रैक्ट देम ऑल, और यू नो देयर इज अ टोटल ऑफ 100% and then you subtract all these from 100, so you get it.
I understand that point, but
Because
like
88.
but like inside the formula, like so let's say हमें ये आ गया हमारा ये y, this is the percentage abundance y. How do you get it? You add all of these. सही है. जो बचेगा वो obviously ये होगा 100 overall तो 100% होगा ना. So this plus y should be equals to 100. That's the idea. Box plus y should be equals
Yeah, divide by 100. You're talking about percentages, so obviously.
Yeah, so like here आपका हर जगह
Otherwise,
yeah, so like basically if you're putting it into the formula, you have to you have to divide by 100 and so on. थोड़ा सा messy हो गया, but that's basically the idea. Hopefully you guys get it. Should I write it out?
Sum them all up in 100 denominator. I think it will be a pretty long calculation, so you will get the idea with it.
Hydrogen halides are compounds formed when halogens group 17 react with hydrogen. The bond polarity of hydrogen halides, so polarity decreases from HF to HI. Explain the meaning of the term bond polarity. How polar the bond is. I don't
No, you have to use the electronegativity wala principle and say it's the pull on an electron, a pair of electrons, a shared pair of electrons by one atom.
एक mark. I would say difference in electronegativity of the bonded atoms.
The idea of it. I tend to explain this one step further now, just to secure my mark agar koi additional detail ho to.
Yeah, I mean like, but
that's usually very like time ka waste hai agar if you're super confident about it.
The meaning of the term difference, acha, and they're like bond in which the centers of positive and negative charges do not coincide, asymmetrical, or there's a difference between electronegativity, partially charged. That's basically the idea. Okay, electronegativity given difference aega, so obviously it would go one way or the other.
But SNA in question is, can you use buzzwords like electronegativity, and do you not have to explain it in terms of like simple electron yahan jayega, electron wahan jayega?
Yeah, to be honest, it varies marking scheme to marking scheme. But like, yeah, ideal scenario, if you pick whatever, if you can predict which words they're using in the marking scheme, to good scene. In most cases, it's not that ideal. So you just write, you explain the concept, you should get the mark. But in this case, obviously, like in retrospect, I'll be like, okay, the shared pair of electron is not distributed equally. Like you can explain it through that, you can explain it through this. Either way should work. So suggests why the boiling point of HF is much higher than the boiling points of other hydrogen halides. So yeah, remember H here is bonded with a highly electronegative atom, which is fluorine. NOF होते हैं highly electronegative atoms. So HF जो है, that would again, boiling point depends on intermolecular forces, right? So this would form hydrogen bonds, right, which are stronger than the bonds that other hydrogen, let's call them HH, other hydrogen halides only. I mean, so
HX.
oh yeah, that's
I convention.
that's a better way to put it. So yeah, so they at the very max they would just have, you know, dipole attraction, which you can call permanent dipole attraction, like depending on which different teachers use different wording, whatever. At the very best, and you know, your hydrogen bonds are obviously, they are stronger than your dipole attraction, so you of the boiling point much higher hai. That's the idea. The much higher is because it's not just with regards to, you know, electronegativity and all का change क्या आ रहा है, it's the fact कि इतना change आ रहा है कि आपने बिल्कुल ही it's a different type of bonding basically. So describe and explain the relative thermal stabilities of hydrogen halides. If I'm correct, is this linking to bond length?
Yes, exactly.
Yeah. So as you go down the group, the idea is your bond length increases. Why is that so? Because down the group, you know, radius increases. So like basically, if this is HF hai, HI would be something along this. Obviously, jitna lamba hoga, the weaker it would get. So bond length increases. I mean,
Okay,
like,
I'm sorry, but
इसमें क्या कर whatever.
that
Okay.
sounded wrong, but
Okay, so bond length increases. So the bond strength goes down, or the bond energy decreases because you need less energy to break the bond. Say bond energy is the energy required to break the bond, so you need less energy now because it's weaker, you know, because the bond is weaker. So yeah,
and essentially because it's further away from the nucleus now, so the attractive force is lesser. So
basically,
इतना उस पे वो नहीं है, force नहीं है.
basically, and hence, so stability decreases because either आप heat करोगे ये टूट जाएगा, but so down the group, you know, because bond is weaker, it's not, they're not as stable when you heat them, like टूट जाते हैं बेचारे. So the equation for the preparation of hydrogen chloride using concentrated sulfuric acid is shown. Use bronze. अबे ये मुझे cool boy लगता है यार. I'm sure इसको European name.
हाँ, जो O के बंदर वो आते हैं ना, slash वो
magnetic flux.
phi की तरह.
Phi मतलब stats पढ़ रहा. Use the Bronsted-Lowry theory of acids and bases. अच्छा, ये जब बोले ना तो वही ना कि proton donor is acid, proton acceptor is base, and you know, every strong acid has a weak conjugate base and all of that. Straying from the topic a little, some people, not a lot, but very some, they're like, yeah, how is normally you donate H positive ion to the acid, that makes sense. How they're like, how is this synonymous to say to saying donating a proton? And the idea here is hydrogen में होता क्या है, एक प्रोटॉन होता है, एक इलेक्ट्रॉन होता है. So H positive में क्या होता है, एक प्रोटॉन ही होता है, न्यूट्रॉन भी नहीं होता बेचारे के पास. So like this is literally just, you can literally just call this a proton. That's the idea. Okay, but back to the question.
It is a proton.
The theory of acids and bases to identify the base. The base here and its conjugate acid in this reaction explain your answer. So whoever is donating proton is the acid and the other one is the base. So इधर हो क्या रहा है, आपका H is donating एक H positive donate कर रहा है ताकि this can form HCl, correct? So this is acid, and hence this would be base, and it kind of makes sense. One is obviously a strong acid, one is just neutral. So if you had to pick, but NaCl. So NaCl was your base, and इसका आपको conjugate acid निकालना है. So that would be HCl.
Yeah.
Because the idea basically conjugate acid में क्या scene है कि once you've accepted the H positive, then you become if you were a base, you would accept like H positive ions. So you know, bases are those that accept proton, and once you've accepted the proton, then you become a conjugate acid. Hamza, do you have, is it 2 mark हैं, but do you have anything to add to this?
I think this is enough वैसे, but when it says explain, I think you have to explain the logic behind conjugate acid. So वो acid वाली logic है, since it has accepted a proton, it can now donate it, giving it acid-like properties.
Yeah. Okay. So since it has accepted a proton, it can now donate proton. जो उसने लिया है वो वापस दे सकता है. In questions like these, marquee seem check करें just to ensure हमारी wording सही थी. Base is सही है. Okay. So whoops. So like base Cl negative ही है. It's not H positive, because if you it's not NaCl. Because if you really look at it, who's accepted the H positive? It's only who's accepted the proton. It's only Cl negative. It's not NaCl. Care, but they haven't explained this, so like I don't know what they're high on. No, अच्छा, M2 इधर है. So Cl base is a proton acceptor, which is written, and that's all we wanted for explanation. So like that's just Cambridge for you. Explain why the reaction of concentrated sulfuric acid and sodium iodine is not suitable for the preparation of hydrogen iodide. So with concentrated sulfuric acid, this is an oxidizing agent, a very strong oxidizing agent. So yeah, and well, if you take it from the top, so if you go down the group of group 7, the oxidizing power, how strong of oxidizing agents they are, that decreases, right? So the idea here was the reason that this could still work is because, you know, chlorine has equal oxidizing power to H2SO4, so hence it resists the H2SO4 to some extent. Sodium iodide के केस में करोगे, so HI won't be made because full oxidation will take place. Complete oxidation is a better way to put it. Oxidation takes place, so turning it into, इससे I2 तक लेके चला जाता है, because HI में क्या है, HI में it still has -1 है ना, so it still has potential to be oxidized all the way to 0. So because there's such a difference between their oxidizing powers, H2SO4 will just oxidize it completely to I2. So you really can't extract.
And H2S.
Sorry?
H2S as well, hydrogen sulfide. It gets all the way oxidized to hydrogen sulfide.
हाँ, वो तो है, but like with if you want to take hydrogen iodide का iodine, हाँ, फिर आपको पूरा reaction याद है तो आप वो भी mention कर सकते हो. But the idea is
there's an alternate explanation for this as well. वैसे you can talk about how as you go down group 7, the reducing ability of these elements gets stronger. So they get stronger reducing agents, and then in return they can reduce the sulfur, the hydrogen sulfuric acid further.
Yeah, so if
that works too, I think.
So like by saying either they're weaker oxidizing agents or they're stronger reducing agents, and if they're stronger reducing agents, वो दूसरे को reduce कर लेते हैं और खुद oxidize हो जाते हैं. So that's what's happened here. HCl undergoes a reversible reaction with oxygen. The reaction is carried out 400 degrees Celsius in the presence of copper, so copper 2 chloride catalyst. So you have CuCl2. Not that I don't think it matters here. Cl, handwriting is very bad. Use the data in the table to calculate the overall enthalpy change of reaction. So enthalpy change of formation you have of HCl की है, you have H2O की है. इसकी obviously, you know, इनकी enthalpy change of formation नहीं होगी. Yeah, what is enthalpy change of formation? You form a substance in its standard state from the elements in their standard states. So you won't have any enthalpy change of formation for oxygen gas because it is the element in its standard state. Chlorine gas is the element in its standard state. So basically, if
Though
basically, sorry.
in some cases now ऐसा होता है कि it gives you a compound in one state and it also gives you the enthalpy change for it to be converted into another state. उस case में it becomes relevant then.
Yeah, but enthalpy change of formation is when you're forming the product in the standard state of the product. So oxygen standard state is oxygen gas. If it had been oxygen O2 solid, then yes. So
I'm talking about other examples.
Okay, you're talking about other examples. Oh, so ideas, you have elements, all the elements here in the standard state. Say elements, jitne jo bhi hai, I don't really care. Either you have 4C, sorry, in fact, I can rub this. So you have 4HCl and it's going to 2H2O. I don't care about the elements here because unki koi formation nahi hogi, right? So what's happening here that you and since so H2O की formation था कि हमें gases में दी हुई है, इसकी भी formation दी हुई है. So this is the enthalpy change of formation into 4 because 4 है. This is the enthalpy change of formation into 2 and this is the enthalpy change of the reaction. Idea basically here is, वैसे you can just minus the 2, but idea here is that you add this. So it's like 4 in, let's say enthalpy change of formation of HCl plus the enthalpy change of the reaction is equals to this. Is equals to enthalpy change of formation of H2O. And what happens then? You just take it to the other side. So enthalpy change of reaction is then you just इसको लो and इसको उससे minus कर दो. So this will be 2 into ये क्या था H2O का क्या था हमारे पास minus 242 and you've taken this on the other side. So this is minus 4 into minus 92. Simplify kar lo, you'll get your answer. State the type of catalyst used in this reaction. Explain how a catalyst is able to increase the rate of chemical reaction. So by type, are they asking about heterogeneous or homogeneous? Hamza?
I don't know about that. I think the type I remember is you used to mention that there's an organic catalyst in the form of enzyme and इसमें case में शायद heterogeneous या homogeneous हो रहा होगा.
Okay.
The first thing that comes to my mind is inorganic, but I think you're right about the heterogeneous and homogeneous.
So heterogeneous catalyst. So homo is like homo is same. Hetero is different. So heterogeneous catalyst is a catalyst which is jiski state hai. The state is different when you compare with the state of the reactants. So reactants here are in gaseous state. CuCl2 solid hoga aapka, so like that's in solid state. So it would be a heterogeneous catalyst because state is different. So heterogeneous catalyst. Explain how catalyst is able to increase the rate of a chemical reaction. So it does so by आपकी activation energy कम कर लेता है by providing a lower energy alternative route or reaction pathway. Hamza, anything else you think we need to mention in 2 mark का ही है बस?
No, this is enough.
So yeah, so heterogeneous, yes, alternate pathway of lower activation energy. That's the idea. So reaction exists in dynamic equilibrium. The reaction was repeated at 10,000 degrees Celsius and the same pressure. The pressure
1,000.
So 1,000 degrees Celsius. मतलब whatever. Okay, sorry. कर लो. Explain the effect on the composition of the equilibrium mixture of the change in temperature. So yeah, they were basically asking equilibrium right jayega, left jayega, and the way I like to remember this is Handlex. So high temperature favors endothermic side, low temperature favors exothermic side. Handlex.
Achha, I try to remember this using its logic now. So if you go up to the reaction itself, Hassan, can you go up to the reaction?
हाँ अभी तुम तफिया करोगे, सही है।
नहीं,
वैसे
तफिया नहीं।
एंथैल्पी चेंज ऑफ
हाँ,
रिएक्शन वैसे आ क्या रहा होगा, पॉजिटिव। हाँ, एंथैल्पी चेंज ऑफ रिएक्शन वैसे नेगेटिव में ही आ रहा होगा, सो इट इज डेफिनेटली एन एक्सोथर्मिक रिएक्शन, बिकॉज दिस इज कोई 482 प्लस आपका, या इट विल स्टिल रिमेन नेगेटिव। सही है, हमें कैलकुलेट नहीं किया लेकिन एक्सोथर्मिक है। एंड व्हाट इज योर ब्रिलियंट लॉजिक?
okay, so the idea is endothermic. I know. Endothermic तब होता है when you absorb energy to break bonds, right? And you want to break bonds in the forward direction to get your products. So if it's an endothermic reaction, you want to increase the temperature, so more reactants can break apart and you get more products. On the contrary, if it's an exothermic reaction, na वही चीज reverse कर दो principle, so you get your logic for having a lower temperature so that it favors that more of the, आपके जो products हैं, they don't break back into the reactants themselves.
चलो, so you have the logic and you have the jugaad. So using the jugaad, forward reaction is exothermic, but either temperature higher increase हो रहा है, so higher temperature favors the endothermic side. So equilibrium जो आपका है, it moves, sorry, bad handwriting. So it moves तो लेफ्ट हो जाता है, या इट गोज, या दिस फेवर्स द बैकवर्ड रिएक्शन, जो भी आपको बोल रहा हो, सही है। एंड state and explain this, because an explanation may, because higher temperature favors endothermic reaction, which is backward. Just quick check of the
You can
mark.
just mention the reaction is exothermic.
Yeah,
You just have to mention the reaction.
सही है। And okay, so because they had the composition of the equilibrium mixture, तो इधर उनको थोड़ा सा मसला है, like shifts equilibrium to the left and decreases yield of products. So okay, so be a little specific. And reaction is exothermic or the backward reaction is endothermic. Both will give the same idea. Okay, so let's go back to red. So 1.6 मुझसे कितना लंबा पेपर है यार?
5 questions
अभी
होने
3
चाहिए.
क्वेश्चन में आए हैं, खत्म ही नहीं हो रहा। I thought like 10-15 तो हो गए होंगे। अच्छा, wait.
हाँ, लग
So
रहा है.
there are only 3 questions?
No, that's not possible. है तो इंडिया वालों के तो मजे हैं अगर ऐसा है.
नहीं, ये फुल लेंथ पेपर है तो like proper, like this is always in the same format. But खैर चलो, जो भी है कर लेते हैं। Okay, so when 1.6 mole of HCl is mixed in a sealed container with इतने mole of O2 at 400 degrees Celsius, सही है, इतने mole of Cl2 and इतने mole of H2O are formed. Total pressure inside a cylinder is this. Calculate the amounts in moles of HCl and O2 in the equilibrium mixture. And इसी से link है ना, right? So 400 degree Celsius, we're just looking at the same degree Celsius. Yeah, and to be honest, ये reaction नीचे लिख लेना आसानी हो जाएगी. 4HCl, 4HCl plus O2 plus O2 goes to 2Cl2 plus H2O. 2 है ना? हाँ, good. सही है, total pressure दिया हुआ है and you're given the moles of, ये क्या हो गया? हाँ, so you're given the moles of HCl, you're given the moles of O2, you're given the moles of Cl, you're given the moles of this. Acha, Hamza,
सबके दिए हैं.
yeah, you'd have to help me a bit here. I remember that total pressure used to divide in such a way that it has some relationship with moles. I think whether he used it, but I don't
Yeah.
I don't remember what exactly that division was.
The partial pressure of the whatever substance or element you're talking about divided by the total pressure is equal to the number of moles of that element divided by the total number of moles.
खैर, लेकिन ये इधर तो मोल मांग रहा है, so अच्छा, so they're saying
first part है तुमने जो
हाँ सही है. So basically they're saying that there you had 1.6 moles of HCl, say, and you had 0.5 moles of O2, and हमने ये किया reversible, इधर 0 था, इधर 1.6 minus x आ जाएगा, इधर 0.5 में से कुछ कट गया.
SN is going to be 1.6 minus 4x.
Yeah, because उधर 4 ले रहा है, खा रहा है. So 4x, the reason being because it's consuming 4 moles of whatever is needed to go to the other side. इधर बस एक ही है, chilling है. And either 2x is formed, either be 2x is formed. Sahi, and using that, the you solve. How do you solve, Hamza?
You know that they've told you that 0.6 moles of Cl2 are formed. So 2x is equals to 0.6, sorry. You find out the value of x, you substitute it in place of every other place, and you add them all up to get the total number of moles at equilibrium, basically.
Good boy, good boy. And yeah, you just substitute that into other x values, and you're good. So calculate the mole fraction of Cl2, which is, so mole fraction is, you know, the number of moles of Cl2 upon total moles at equilibrium. Correct?
Yeah.
So yeah, so
Yeah,
that's correct. Your mole fraction, and you know that because you will know the number of moles of Cl2 and you will know the total moles of at equilibrium aapne wo nikal liya, and hence the partial pressure of Cl2 in the equilibrium mixture. So you just multiply this by total pressure. Correct me if I'm wrong.
Yeah, and you get your partial pressure.
So yeah, and you'll get your whatever you need. In a separate experiment, a gas, an equilibrium reaction mixture was found to contain the 4 gases at the partial pressures shown in the table. So you have gases, unka partial pressure diya hua hai. Use this information and the expression for Kp to calculate a value for Kp. State the units of Kp. So just input, I believe. Is that it?
Values तो आसान है, बस वो units का input करना है सर.
So values तो आपको input करके Kp तो मिल जाएगा. Just input all of this. Units, these are pascals, right? Partial pressure is also given in pascals. So ऊपर देखो, so ऊपर आपके पास you have pascals square into pascals square. नीचे you have pascals power 4 into pascals 1. So you have pascals 4 upon pascals 5. You have pascals minus 1. So yeah, simple indices. The reaction is repeated without a catalyst. State the effect of this on Kp. Unchanged?
Unchanged. The only thing that affects Kp or Kc is temperature.
And the idea here is because Kp depends on moles and the molar ratio, which depends on the position of the equilibrium. And if you remember, catalyst does not affect position of equilibrium. ये थोड़ी सी लंबी वीडियो हो गई. So sorry.
Charles law वाला scene. Charles law और वो वाला scene था.
चलो Charles boy. So that's the idea. Let's continue the next question in the next video.